Hi everyone, good morning. So I think we can, I think everyone is here, so we can start our class for today. So, mm, oh, 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 oh. so okay, so this week is already week 8, so we should cover these three chapter together by right this week. However, we only, I think we should focus on this chapter 6 first because these two chapters, chapter 7 and chapter 8, I already check out the lecture note. They are short lecture, like 20 pages. So we will only focusing on this chapter 6, object interaction, because we have like 40 pages to go. So that one for our lecture. So this week, I'm very sure you have tests for other subject. Same with me too. I have tests with my subject, 2 or 3 chapter in week. According to this draft, this course line, yes, they put 3 chapter in week, but don't worry, I will only focus on this one, chapter 6 first, because like I said, I already checked these 2 chapter, chapter 7 and chapter 8, which I will forward to next week. But this one is quite easy. I already checked the chapter, don't worry. Today or this week, we only focus on this one, chapter 6, okay? And then, mm, this week, not this week, as I already informed, in case some of you wonder, do you have midterm or test for this course? No, you don't have midterm or test because your assessment will be only from your assignment, which is part 1 and part 2. And all of you already submit your part 1 last week, and then we will proceed with part 2 on your assignment. But I expect this week, I think you should focus on your test other subject. So this week, it's okay if you don't want to focus on your part 2 of your assignment, and then you will have your examination. Okay, so no test for this week. So for your assignment portfolio part 2, I think we will only talk about, uh, because I already see this part 2 in the assignment specification, but we will see this part 2 next week. So this week, you guys just focus on your test. Okay, no stress on this subject for this week at least. I think that's all for assignment. So last week we stopped here, chapter 6 on object interaction. Yes, no midterm. This one, yeah. Okay. So yes, no midterm. I think this one already, I post this since last month. No, no. Yeah, last month. So no midterm for this week and this week, this course. So let's proceed with our lecture. So before we continue from where we stopped last week, any question? No question. I proceed. Okay. So last week we stopped here at the. Okay. So last week we stopped here at the sequence diagram on the interaction operator on the here on the sequence diagram on the interaction operator. So before I proceed, let me recap with you guys first. What is sequence diagram? Okay, let me recap with you guys what is sequence diagram. So sequence diagram, like I already like what we already covered last week. Sequence diagram is, this is the overall diagram, overall view of sequence diagram. So sequence diagram is actually the object interaction that arrange in a time sequence. So let me recap again with you guys. This is can be an object or class. So it is an interaction between this object or class in a sequence time. Okay, this one is the sequence diagram. So last week we already what is the notation of the sequence diagram, and then this operator 2. So we stop here last week before the exercise. Okay, so this is where we stop. So last week I remember I asked you guys to do this exercise one, which is a sequence diagram. Sequence diagram for a deposit cash. Last week I show you a video, but that one is on the cash withdrawal, ATM cash withdrawal process, a YouTube video. This one is a deposit cash, so it's quite different. The video is withdraw, this one is deposit cash. So any of you done this exercise? Rachel ada sini. Rachel, have you done the exercise? No. Then Ian, have you done the exercise? Busy with assignment. So I assume none. So I prepare. Actually, it's quite easy, but I already prepare this one, right? Yeah, this one. So I will be wait this one first. Hmm, 1 second. Okay. So they ask us to uh construct a design sequence diagram. So your diagram should be, it is recorded, right? Yeah. So your diagram should be something like this. So let me explain first. So in a sequence diagram, of course, we have this. This is what we call as an actor. I think you guys know already what is this notation mean. This is an actor. And then here we have a lifeline. So lifeline here can be an object or a class. So referring back to the definition of sequence diagram or the concept of sequence diagram, it is an object interaction to object interaction in sequence time. So they ask you guys to draw this diagram named as deposit cash. Okay, so this is the example of the deposit cash for the sequence diagram. As you can see here, this is the lifeline, the object or the class, and you can see this is the message. If you guys remember what I explained last week and in the first or second week, I don't remember which week, but I already explained what is message passing. So message passing is a way for the object to interact with each other. So this is a message passing. So I think you guys can check this later. I will send this later to you guys. uh So this is a process which a step by step or a sequence or a process in sequence for a actor here, which is our client, to with or to deposit the cash. So I think the sample diagram here is quite easy because there's no, here they only use the, this is a bar that we to show the either the object here is active or not. So it's quite easy because they don't use the FOC. FOC, yeah, FOC. So if you guys remember what is FOC last week, FOC is a focus of control, which means to show there's a current process on that particular class or object. So this one you guys can check later because the process is quite easy just to deposit cash, but you guys need to know what is the involved object or class and what is the message or the process that occur between the actor to the object or between the object themselves. Okay, this one I will show to you. I will send to you guys later. I don't want to take too much time on this because first this one is quite easy and we have 40 more page to go for today. Okay, so can I proceed with my lecture? Yes. Okay. So here this is the exercise. So this is where we start today for our lecture. Where's my... Okay, so let's start with our lecture. So here we are still in sequence diagram. So like I said just now, sequence diagram is a diagram that show the interaction between object in a time sequence. So of course there's a complexity. Complexity is the, you know, you guys know this complexity is like the a complicated diagram which to or what we call as a crowd diagram. So how can we tackle this complexity in a sequence diagram? So first, here we use interaction fragment. So we will see later what is interaction fragment, and then lifeline for subsystem or group of object, continuation, and interaction overview diagram. So these three technique or these three method to solve this complexity we will see later. Okay, by the way, before we move to the next slide, I think let me explain first. So interaction fragment, the first method is interaction fragment. So what is interaction fragment? So interaction fragment is to is actually interaction fragment in our sequence diagram is to allow us to group related message in a sequence diagram. That means we will include or we will group a message in our sequence diagram, but we will see later how should we group or how they will be grouped in a sequence diagram. And lifeline for subsystem or group of object, this one is to like we are adding lifeline for subsystem. So if you guys remember what is lifeline, this is lifeline. So we are adding lifeline to our subgroup or our object. And then continuation we will see how from one sequence diagram we can extract and then we can continue the process in another sequence diagram. And interaction overview diagram, this one is not in this chapter. Okay, so first we will see on the interaction, fragment. So like I said just now, interaction fragment is actually to allow is for us to group related message in a sequence diagram. So here, okay, here as you can see here, this is a reference. So this is an interaction. 1 minute. So sorry. So as you can see here, this is a reference actually. So reference interaction operator indicate interaction occurrence that reference an interaction fragment. So interaction fragment, like I said, it is actually a message. So the cache showing the message enter. If you guys remember, this is a notation of message. But also last week I explained on the notation of the message respond message. So it is a message, but it's used different notation. So this is a message. This is a message list campaign that enter this enter interaction occurrence. Interaction occurrence, that's interaction occurrence mean this is the interaction that occur in these two object within this uh, times in the sequence of the interaction. So here showing the message enter this interaction occurrence. Okay, and then we will see later. We will see this one is still from the same sequence diagram, check campaign budget. Here in the check campaign budget, you can see here there is a process which refer as list client campaign. So this reference, we come out with this SD sequence diagram. That's mean we we extract this from this list client campaign to another sequence diagram here. Okay, so here interaction fragment that is referenced in check campaign budget sequence diagram. So that's mean this sequence diagram, if you read to here, if you refer to here, that's mean the meaning of this particular message. Is it message in this box here saying that this list campaign budget is from this SD, this sequence diagram. That means they take from this to this. So here they're still the same with the previous slide just now, showing the message enter this interaction fragment. So here is, like you can see, this is more detailed. So here they have this looping function for all client campaign, and then there's one message between this client object and this campaign to communicate. Yeah, to communicate. So this object send this message to this object to get the campaign detail, and there is a looping process here. And then this one is still using the same sequence diagram and still under the interaction fragment to solve this complexity in the sequence diagram. As you can see here, if you go back to the get campaign budget. Okay. If you see here, this is a sequence diagram. Here is the get campaign budget. If you go to the original sequence diagram, which is this one, check campaign budget, here is the one just now. The first one that I show you guys is the list client campaign, and the second one is the get campaign budget. So from this reference, we go to here. You see the SD, the sequence diagram name. So like I said, the sequence diagram name is like our use case name. So this is the sequence diagram from the original one just now. So here interaction fragment that is also referenced in check campaign budget sequence. This one, the one that I said seconds ago. This one we extract. I mean, this one is we get from the original sequence diagram. So this is the process. As you can see, there's an interaction between the actor, campaign, and advert. And then you can see this is a message and a process. And this one, what we call as last week, I said this is the reflexive message. So if you guys remember what is reflexive message, that mean so reflexive message is a message that we send to ourselves. So here this is an object send a message to itself. Okay, so here I think this one is straightforward because from these two diagram, this first one just now and the second one is taking from here, first one and second one. So the interaction fragment is, like I said, is to allow us to group related message in a sequence diagram. This is a message, this is a message, and this is a reflexive message. Okay, so I think that's all for interaction fragment. So what you need to know in interaction fragment concept is a message like grouping. No, it's not like message grouping. Yeah, it's kind of message grouping. That means we allocate uh our group. It's not our. We allocate the group with the message related in a sequence diagram. So that one is interaction fragment. I think that one is. This is not complex actually because it's just the message in the related sequence diagram. That one is the first one, which is interaction fragment, and then second from our list this now we have subsystem. Okay, so what is subsystem? So here we are still in this add a new advert to a campaign. This is our sequence diagram then. So this is our sequence diagram name. And then as you can see here, um, left line presenting the interaction between okay, left line for subsystem or group of object. So actually to tackle or to solve this complexity in our sequence diagram, that's mean we add lifeline like I said last week, and just now lifeline is this one. This is the lifeline. So 1, 2, 3, 3 lifeline here. So to handle the complexity is by adding lifeline for our subsystem or group of object. So here, this one is a new lifeline, a new class. Yeah, a new lifeline. It can be class or object. So we are adding this to handle the complexity. This method, if I'm not mistaken, is the same with our previous. I think there are some part in our previous lecture that's using the same method to solve the complexity. I think that one is in multiplicity, but I don't remember. But I'm very sure there are some method that like adding the class to between the entity to solve the complexity. So same with this one. So this is just another lifeline. We create another lifeline to solve the handling complexity. So like I said, complexity is when the relationship or the association between our class and our object is too complex. So we need to um, they want to like solve it. So they add another line for system or group or subject. So lifeline representing the interaction between group of object. So here, let's check. Okay, so that one is for this patch, and then we move to the next patch, which is still lifeline for subsystem or group of object. So here, lifeline for subsystem. Okay, so here, as you can see here, sequence diagram reference in the add a new advert to a campaign. So this one is a name for our SD sequence diagram. Add a new advert to a campaign. So as you can see here, there is a message that sent to this group, this lifeline or this object, and then you can see this is the process to add a new advert to a campaign. So from this sequence diagram, how should we know um, what is the process or what is the final, what is the purpose of this sequence diagram is by checking this one first. They said this is the sequence diagram name, which is add a new advert to a campaign. That means this is the function that they should process for this particular sequence diagram. So we relate back to the concept of sequence diagram. So because sequence diagram is the process or interaction between the object within a time. So here new advert. So this so here in this process here advert this mean that this is the last process or the last process or the last what is the expected process for this sequence diagram. So in case you're wondering what is the last process that performed by this SD, as you can see here, this is their using reference. So we just check on the last process here. So here also add new advert, of course, because now here they already use the SD name as a new advert and campaign. So here is the last process to add a new advert. Same goes to this one. This one is client campaign add, and then this one is a reference in this SD. So the last process is here to add new advert, add new advert, yeah, new advert. So I think because this one too, honestly, I did some study or revision. Yeah, I did some revision because I don't really like remember this diagram. But then what I did first, I go to, of course, like I said, we need to know the notation. So we need to know the notation, what is the use, and of course, before we go to the notation, we need to know what is the concept or how it works for any sequence diagram. So for this sequence diagram, I check what is the concept for sequence diagram, and then I study what is the use of each of the notation here. And then after we already understand the sequence diagram, it's easy for us to proceed with the lecture. So that one is now is for lifeline for subsystem. So the third one is the continuation. So continuation is actually for this sequence diagram, continuation is actually like we are carrying something forward. That's mean from this process we continue or we proceed proceed we continue or we proceed, yeah, from this process to another sequence diagram. So in sequence diagram, continuation will be only used in sequence or alternate. Yeah, sequence or alternate. So as you can see here, this is a continuation. So like I said, continuation is like we forward. Yeah, we forward, we carrying something forward. So as you can see here, this is the sequence diagram to authorize expenditure. So three we have three objects here, lifeline A, lifeline B, and lifeline C. So here there's a reference here, reference to calculate the cost. So this is the reference here, calculate the cost. Like I said, to solve the complexity, we can tackle this or we can solve this continuation. So from this reference, we create another sequence diagram under this one particular process to calculate the cost. So here we have the sequence diagram for calculate cost. So as you can see here, under the calculate cost, we have, they're still using the same, of course, the same lifeline A, lifeline B, and lifeline C, because here from the original sequence diagram, this is the interaction between these three objects of group, these three lifelines. So we do the same between this calculate cost as the sequence diagram. So here is the detail. Yeah, detail. If you see here, if you compare to here, they're using detail information. It's not information. They're using, they show the message, what is the interaction between the object. And then after this one is same with this one. But you guys can see what is the difference. So this one, of course, we have the same one, which is alternate. Alternate. So if you guys remember in our last week, alternate is like if else, yeah, if else function. So here we have under this alternate, we have this reference to identify under spend. So here, like I said, this one is more detailed. This SD calculate cost is more detailed to authorized expenditure. So here under the reference, they have this alternate function, which is within a budget, or within the budget, else it is the budget spend. So this is the continuation. So continuation, the because I checked this one too. This one is the notation. That's mean if you use this, this is the notation for continuation. That's mean it will carrying something forward. Usually it is a process. So as you can see here, this is what we call as continuation. That's mean we proceed, or we proceed. Yeah, we carrying something this to this one. And of course, it is more detailed. If you guys can see this to sequence diagram. So continuation are used to link sequence diagram. So this one I said just now to carry forward the process. So it is a link to link the sequence diagram. Okay, so mm, there are three method. First now is the interaction fragment. Second one is the lifeline, adding lifeline, and the last one is the continuation. That's how we handling the complexity, or how do we solve the complexity. Actually, in our diagram, not only for this sequence diagram, in any diagram, complexity is a very common, or very, yeah, it's a common thing. It is not wrong for you to, for us, not only for this diagram, for us to have any complex diagram. But of course, when we want to present with because like I say, OOAD is usually for BA, business analyst. So if you want to present to others, we want to make other understand what we are doing, or what we are presenting. Of course, we need to like break the complexity so that people can understand. So for this particular sequence diagram, there are three methods like I explained just now. So before I proceed, do you guys have any question? No. Okay. So I proceed with this one is notation. So I proceed with notation. So this one is a synchronous message. So a synchronous message, before I go to this point, a synchronous message is actually a message that is sent when we, or uh, for example, we have these two objects. Yeah, regardless the process here, let's say we have these we have these two lifeline, these two object, for example, lifeline A and lifeline B. So a synchronous message is actually a message that they doesn't need to wait for a response. They doesn't need, for example, this is my object A, this is my object B, regardless the process. So for example, object A, I send a message to an object B. So a synchronous message is a message that they doesn't need this object B to return or to respond to them before they sending back the message to object A. So different with synchronous message. Synchronous message, I think I explained last week. So a synchronous message here is, so here, like I said, drawn with an open, this is the notation, arrowhead, so does not cause the invoking operation to halt execution while it waits a return. That means they doesn't need this object B just now, like I said, they doesn't need them to respond before they return back the message to object B. That means they process themselves, they doesn't need this one to trigger to respond to respond back the message before sending back. So that is a synchronous message. Does not cause the invoking operation to halt execution while it waits a return. So that is a synchronous message. So here, so here OSD is interaction name. So as we can see, there are two object, two lifeline class A and class B. And okay, before I explain, I asked you guys already last week, between this class A and class B, which one is the most active one in this interaction name sequence diagram? Between class A and class B, which one is more active between these two? Yes, it is, where is it just now? It is, eh, it is class A. Why it class A? Because like I said, this is a bar. This is a bar to show if the object is active or not. That's mean they are active here. If they're using here, 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 here. That's mean here, for example, here, this is a bar that show they are processed or they're doing something on ah here is a bar that they show that they are active. That's mean they are active, they can be processed or they're doing something. That's mean, for example, here, if you go to this advert or lifeline here, they're only active or they're only processing within this notation, within this bar here. The other, that's mean there's here, that's mean they are idle. Idle, that's mean they're not processing something. So they're only active in this part of their lifetime. Yeah, in their process, they're only active. That means they're only processing something or doing something in this part. The other, they are idle. They're not waiting, they're not processing, they're not doing anything. So I think, I'm not sure why I asked you. Maybe I saw somewhere they ask this kind of question, which one is active. By the way, that's the reason. So here, as you can see here, T stand for, this is a sequence diagram, an active object. Like I said, an active object, because how you know it is an active object? Based on this bar. Okay, so here, from what we said just from what I explained just now, the asynchronous message, if you see this notation, check back with this one. This is a notation for asynchronous asynchronous message. So here they are sending a message from this object to this object to to process something, and then here is class B, but they doesn't need to wait for this class B actually to respond. Yeah, to respond the message, and then they call back. Call back, that's mean they return back this message. This is the request return, but this is a asynchronous message. So here, as you can see here from this one, this is a callback. Callback, that's mean they send back this message, or they roll back the message to the original sender, which is lifeline class A. So this one for the time, I think somewhere, because I already checked somewhere in this lecture later, you guys, I will explain what is the time. What's the term? Timing diagram. Timing diagram. So if you don't understand this part now, it's okay, because later we have this part, timing diagram. But what is important on this slide is a synchronous message. Synchronous message that doesn't need to wait a object to respond to them before they can roll back or call back, before they can return awaits here. Invoking operation to hard access, it awaits a return. That means they can call back on their own. So same goes to this one. This one, message object A sent to object B, and then explaining some aspect of this execution currents. So maybe they're processing something. However, a synchronous message doesn't need them to call back or return back to the original object. So that is a, son, a synchronous message. Here is the duration constraint. This one, like I said, we will see later, but let me explain for this diagram. Duration constraint is a process for actually for, it's a time taken actually to process something. So here is like the, in this sequence diagram, multiplication operator is actually looping or repetition. I think somewhere too, maybe in this lecture, we will see what is the multiplication operator here. By the way, this is a looping or a repetition in the diagram, sequence diagram. So like I said just now, also duration constraint is the time taken to process this. What is the time taken from this? Observation and callback take time. Observation and callback. Observation. Observation.
Oh, I mean the signal, the
Signal
message.
here. This one.
Yeah, a bit confused why they slanted downwards like that.
Oh, this one.
Yeah, both of the
You
things.
mean like there's like a slope
Yeah,
here?
there's a slope. Yeah.
Yeah, this is a slope. So actually, okay, thank you, Calvin Shark. So here, like, this is what we call a slope. A slope that's mean in mathematics, I think it's a gradient, but yeah, I think what, by the way, that's mean y from this to this. That's mean like I said here, this it bar showing the process of something. That's mean in this class A, this process start within this in their lifetime, but in this class B, the process only start here in this their in their sequence time. So that's why it's a slope. Actually, mm, 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 actually duration observation. Actually, it's not, uh, I won't say it's not a constant, but because of course between two objects there are different time of processing or doing something. So that's why there's a slope here. This is what we call a slope because there are different time in processing or yeah, it's a different time between an object to process something. Doesn't mean, for example, doesn't mean when we want to process this in class A, we also need to process this in class B. It's actually, it's up to the process actually, but that's why there's a slope. That means they only process whatever they send or whatever they do in this time. But if you go to previous lecture slide, usually I think this one is the first time you guys see this. Yeah, this one is the first time you guys this see this slope here. By the way, that is the reason. That's mean they have different processing time between the two objects. Yeah, so that's the reason. So Kelvin Shark, did I answer your question? Mm, later, this message also recorded. So that's why I reply. So that's the reason. So different processing time between object or lifeline. That's a good question because this one I noticed too. This one is the first time since the lecture or the slide. So, oh, here, it's actually here. The one I said just now, the duration constraint. Mm, so here they use this H2O. So H2O is a water. So here, so here H2O is a water. So okay, H2O is a water. So here is the time constraint. That means you can see this ice and this water. That means they are in two different states, which is ice and water. So time constraint is actually how long the process to take to change the state of this, change the state, change the state, yeah, to change the state between two object between ice and water. So as you can see here, ice is they have this melting process. So to melt an ice to water, they take average around 1 to 6 minutes. So this is the process and this is the step. So this is the time taken to melt the ice into water. So here too, we have a person and we have this condition, sleep and awake. So 5:40 a.m. to 6 a.m. So if you go to your note, you can see, you can hover to this diagram. So here it's explained that the time that should we wake up is between 5:40 and 6 a.m. So that is actually time constraint to show how long the process to take to finish something. So I think time constraint is quite easy. Time constraint is quite easy. So because time constraint is only to show the process to finish or to complete something. So here, as you can see here, duration constraint, that means this is the time taken to process this process in object B, object called class A, and this is the time taken to process in class B, object B. So like I said, they have different processing time. Okay, that is time constraint or duration constraint. Duration constraint and time constraint. Okay. Mm, so here is the syntax. Syntax is how, or the rules, the syntax uh to draw, to visualize sequence diagram. First, we need to decide at what level you are modeling the interaction. So here is all, actually we just need to read this part, but I highlighted this part for my own reference. So we need to decide at what level you are modeling the interaction, because why sequence diagram is a diagram that show interaction between the object, in time sequence. Like I said, different object have different processing time. So we need to identify at what level, and then identify the main element involved in the interaction. Main element first, of course, the entity. Here, this is the entity. This is what we call as entity. If you have an actor, so we need to identify all the actor entity involved. It can be other elements, other elements such as entity, message that involve, or any process that involve. So we need to identify what are the elements for the process, and then consider the alternative scenario needed. So alternative, like like what I explained this morning. Alternative, the one that if else. That means if not this process, what should happen or what should occur. Alternative. I won't scroll back because I explained that. So that one is alternative. If you're still not sure what is alternative, you should check back the lecture last week, because I'm pretty sure I touched this part. And then identify the main element involved in the interaction. This one should be same more or less with the second point. It is the same actually. Main elements like I highlight here. Draw the outline structure of the diagram. So outline structure is like the frame, yeah, the frame of the diagram at the detail interaction. So like I said just now, here after we already identify our main elements. So our elements can be, for example, the one I said just now, message. So how to detail the interaction, that's what we call as a message passing. Or how does the object or the lifeline associate or relate or communicate with each other is using the message. So that's how we are going to add the detailed interaction. That's mean from one lifeline to another lifeline, what is the message sent or what is the process sent. Okay. So for the next one is check for consistency with link sequence diagram and modify as necessary. Link sequence, but link sequence is Where did I see this link sequence? Wait 1 minute. Link sequence. Link sequence. Consider and modify as necessary. Link sequence is the continuation. Just now, continuation diagram. So like we need to cross check from one diagram to another diagram, and then check for consistent or model. So this one is the most common one. Of course, we need to consistency is actually like we need to cross check if the message or the process or the object is correctly associated or linked together. So check for consistency with other UML diagrams such as class diagram or model. So we need to like cross check what are the process between this SD and our UML diagram. Actually, not class diagram, it can be other diagram. So we need to check for consistency. We need to cross check the function. Okay, so next we have method to class. Let me check. Okay, so that is the syntax for sequence diagram just now. So here, so here we move to sequence diagram to add method to class. So as I scroll here, there's no explanation what is method. So let me explain what is method. So let me explain what is method. So method is actually like a process or procedure that associate with that particular lifeline or object. So here, here, no, here, right? So here is the sequence diagrams to add the method to class so that it will be more detailed. So we will see later what is method that can be added to a class or how to add method to a class. But like I said just now, what you need to know is method is a process. A process, what is this class or object or what we call as a lifeline can do or can process. So I will skip this one because the X is actually the same with the next patch. So you just, so I skip this one. I will explain in the next one here. So if you see with the previous slide, it is the same except for this part. So this part, I think you already familiar with your, since your previous lecture. So here is the, I won't ask you what is this, what is this, what is this, because I already asked many times. This is a class name, this is an attribute, this is a procedure or function that can be performed. So like I said, this is the class diagram from the previous slide. So here, the class name, we take this class name, we take this class name from here, ren UI. So here is ren UI. Same goes this customer control. This is customer control. This is customer, and this is customer. This is a normal class name from this one. You just take this one from this one, and then the second part, as always, this is our attribute. So here they didn't state any attribute, so it is empty. And then the last one is what we call as a method. Like I said, method, it can be message processing or it can be what the, here, it can be what the class should, a message that a class should display. So if you're referring, we take this object, uh, object ren UI. So here, and then, okay, last time, I remember I said this in our class. For our class, if you don't have the message or if you don't have the processing, even if you go back to check our lecture note, if you don't have this one, you can only write something like, oh, just this. Let me, okay. Mm, Operation or message. Last time I remember I taught you this. I taught you this. If you don't have your operation or a message, you can delete. Hello. Sorry. You guys can hear me now, right? This is my second time already. I accidentally turn off my laptop. So what I want to say just now, previously in previously in our lecture, I remember that if you don't have this particular column here, that means from your class diagram, if you don't have operation or message, you can only show this class and attribute here. But for but for this one, for this diagram, even if you don't have the attribute here, you need to draw this column. Do not leave out this one particular column. So let me repeat. Last time I remember, and that is a correct syntax too. If you don't have this process or message, you can leave it like this. People will, even you don't have any attribute, even if you don't have this is the attribute, this is the class, people will know this is the class and this is the attribute. But for this one, you need, even if your attribute is empty, you need to leave it empty. Do not delete this column, as you can see here. So let me go back. That one is the syntax is now. So let me go back with the method. So like I said, method is a process or any message that should be displayed. So display. So here, ren UI, our object or lifeline is ren UI. So this is the attribute, no attribute, as you can see from here. So leave it empty. And then we have this check rating. So how can we get, or where do we get this check rating here? Here, this is the process, not the process, what I'm trying to say, this is yeah, this too is the process that this object should process in his, or in it, sequence. So first here they need to check rating, so you just copy this, you just to include the message or the process in your class, you just tag whatever the process that received by you. You do not tag whatever sent. You just include whatever received by the class. For example, here we receive check rating. So we receive check rating. So we should process this check rating. So we include here check rating. And then there's a second association in this trend UI where we need, or where it send out the message. So that means they doesn't need to process verify rating process in their process. So we doesn't include this one. And then we have this 1.2. We have a message that we send. This is what I said just now, reflexive message. So I send out this message and I will receive this message too. So this is a reflexive message, and then I receive this message. So I put it here. So display rating, and the rating is in, this is the data type. I don't want to explain this data type. You should know this. Okay, same goes to the second object, customer control, our class name, and then we receive only one message. That means we only have this one function to process. Even though we have three interaction here, one, two, three, but we only need to process this one because we receive this one, but we send out these two. So like I said, we process or we include what we process. So the last one is customer. We receive it received two process which is this one and this one. So we just include. So I think that one is quite straightforward. Okay. Same goes with this one. So here actor, okay. So here is the same with the previous one. We have three objects here. We have one, two, three. Okay. Here, if you can see, let's go to this one. Let's go to this one first. 40, 55, 90. So let's go to this one first. So Hmm, I'll explain only this part. The other you guys should check later. So first one, this is the object or the lifeline. So we receive this process, like I said, we will process this message. So check rating void. So it should display rating. It should display the message rating. Like I said, this one, the method is not only the process, it can be a message. So after they already process this check rating function, they should display rating. So rating is character and is equal to void. Same goes to this one. By the way, what's important for method, like I said, you need to know. It's not you need to know. It is a function or a message display that related to your object or your lifeline. Same goes to this too. Okay, so that one you check that later. So okay, so next is model consistency. So what is model consistency? So one, two. Okay, this one should be. Okay, as you can see here, the allocation of operation to object must be consistent with the class diagram and the message signature must match that of the operation. Can be enforced through case tool. So let me explain this point first. So model consistency is that mean our object must sync or must receive or send the correct object or that must match with the operation. So it can be used or it can be, it's not it can be used. Model consistency can be achieved using CAS tool. So CAS tool is actually any computer aided software engineering tool. So CAS stand for computer aided software engineering tools. It can be used any tools. So that one is for the first one. And then every sending object must have the object reference for the destination object. Of course, this one for the sending and the receiver object for the message. So either an association exists between the classes or another object pass the reference to the sender. This issue is key determining association design. See that now. And then message pathway should be carefully analyzed. That means again same with the receiver. Yeah, the receiver of the message. So they need to send the message to the correct object. So all form of interaction diagram should be consistent and message on interaction diagram must be consistent with the state machine for the participant object. Participant object is the what involved. I mean the object that involve the class that involve the lifeline. And then implicit state change in interaction diagram must be consistent with those explicitly model instead machine. That means if we have any implicit is something that is not clear. So something that is not clear, we need to diagram a model that should have a clear interaction between the object. Okay. So for example, this one, I think this example. So, no, this one is for the next chapter. So collaboration communication diagram. Okay. So for this one, I don't think these two slides have a question because this one is straightforward. You guys need this one. I leave it to you guys. This is a syntax for you guys to read. So we move to right now. We move to next. 32. So we move to next chap. It's not chapter. Next sub chapter. So we have here collaboration and communication diagram. So I think here in the slide they doesn't explain what is collaboration and communication diagram, but let me explain what is collaboration atau or communication diagram. So, collaboration or communication diagram is a diagram that like show the extension of object diagram along with the message. Show the extension of the diagram along with, we have different type of message here, along with the message that that send or that travel from one object to another object. So this is a type of message. So like I said, collaboration message is the extension that include the message from one object to other object. So let's, okay, so let's start here. Okay, so here we have one, two, three, four. So we have four four type of message here. You guys are already familiar with this type of message in this lecture. So this is a simple message, the one that we already, oh, we always see, add new advert. So the function is add new advert. And then second, nested call with return value. The return value is placed in the variable name. So nested is the last time already explained. Nested, that's mean function within a function. So this is a process where, if you remember, we have in, for example, in alternate or in reference, we have a alternate function. So the return value, this is the return value. And then this is our conditional message, the one in the previous, in this lecture too. Conditional message, that's mean it is like alternate function, if else function. That means we have condition to check between, condition to check, yeah, we have condition to check, that is conditional message. So you guys read this, but conditional message is a if else function where we need to check the condition. And then synchronization with other thread. So synchronization is like synchronize with other thread. For example, here synchronization is like, I think you know what is synchronization. That's mean they are sync is like what's the term sync? I think you guys know what is sync. That's mean they are sync together. Same, yeah, kind of. So this is the type of message: simple, nested, conditional, and synchronization with other thread. Thread is other element or other object. So so here collaboration, communication diagram, message label. So here we have few actually type of message. um, yeah, type of message. So constructor message is actually when we want to create a new object. For example, customer, same name as the class. That means we want to add, it's like we create a new object. That one is constructor message. This one is destructor message. I remember this in early of our lecture last week. In this lecture not two, there is one destructure message. So destructure message, like I already explained last week, if we no longer if we no longer need, I don't want to scroll back, but yeah, somewhere in the earlier for lecture, when we doesn't need that particular object, so we can destroy. So that one is destroyer message. So read message. So request the target object provide some information. That means they are expecting some return message. Okay. Update message request the target object to update itself based on the information provided in the message. This one is quite straightforward. So that means the new message sent with some, the message sent with some new information for the receiver object to update. update their maybe the data or any information. So this one is collaborative message for collaborate like request for collaboration request. So collaborative message is sent to request to send for a request to do a collaboration in any process. So you can read here, and then this one is input output message for GUI object. So this one is IO message. Okay, here as you can see, this one is display balance for the in display balance. This one is the output, and input is the pin number. So this one is the IO message. Okay, and then next we have diagram that show the process that include different type of message from the previous slide. So here as you can see we have three object, three class: client, campaign, and advert. As you can see here, the direction in which link can be navigated may be shown if required. I think this one you should know already by now. That's mean this process or this object send a message to this object with the direction of this arrow. Okay, that's why I said you should know this by now already. So what the campaign want is to get cost. So the campaign want to get a cost coordinates to show the interaction with a single operation. So yeah, in this single operation, so this is the message from this to this. Client send a request to check the campaign budget into the campaign class, and then this actually is in sequence one, two, and this one maybe three, and then campaign check overheads reflexive message. This one, the multiplication. I'm not sure where I show this, where I see this notation, but um, this one is multiplication, but in a diagram, it shows the like it's not iteration, it's looping or repetition. I'm not sure where I see this. It's not in our previous lecture, but this is the notation for looping or repetition. It's here actually. I take back what I said. So it's here in this lecture note. So here, this is the notation for collaboration and communication. So iteration and looping, like I said, this is the notation actually here. This is a condition. This is a condition. This is a condition I equal to I and number is equal to next integer. So that's mean here. This lecture note is copy paste from some website. So iteration is indicated with a asterisk, asterisk, and optional iteration cause the following sequence number. So yeah, this one is iteration or looping. We know what is iteration and looping, right? So I don't want to explain that part. So conditional message. So conditional message, like in the previous slide, conditional message is like there are conditions that we need to check, which like alternate the if else function. So here they have a condition, they want to check color is equal to red, then calculate the process. So this is the notation for conditional message where they need to check on the condition. This one is the one just now. When we want to when we want to create a new object. So here we have cell. That's mean we want to create a new cell. So create message with optional initializing parameters that will normally be interpreted as constructor call. So this is a notation when we want to create a new object. So cell, this this is not parent, this is bracket. So cell is equal to new. Okay, this is the notation here. Empty bracket. Then Then okay, that one is for create new object just now. And then we have this one is the just some point to explain. So collaboration or communication diagram is usually represent the detailed object interaction that occurs for one use case for one operation. And then it shows the link between objects that participate in the collaboration. No time dimension. Sequence is captured with sequence number. No time dimension, but it will capture with sequence number. So sequence number are written in nested style, for example, 3.1 and 3.11. I think just now I saw this one in sequence. That means this one is first, this one is second. Usually it will write, but we will see later how it will read from sequence number or nested sequence. Indicate nesting of control within the interaction that is being modeled. So that one I leave, this one I leave for you guys to read. It's like the syntax for the sequence or collaboration diagram. So next we move to this prototype example. So the same prototype used since our first lecture for the campaign selection. So we have three prototype here. Oh, we have three prototype here to add new advert to a campaign. So here this is the dialog initialize the uh, initialize interface. So here we have three. They have three client. This one you read this one. They have three client, and then they need to select the client campaign listed. They need to select the client, and then this client selected will show what is the campaign available or the campaign that are listed in the for them. And then this one is the when the user click on the particular or specific campaign, they will uh lead to this one. And then this one is actually a prototype to show, but we will go to see later what is the diagram to show this communication between this process. And then after they already select the campaign, this is the advert that they can add. Okay, so that one is to add new advert into a campaign prototype. So this is where we should go actually. Okay, so collaboration communication diagram analysis. So like I said, how to read the process of this communication diagram is by this. So 1, 2, you see the number 1, 2, and then you go to 2.1. This is in sequence 2.1. And then you go to 3 and 3.1, 4 and 4.1. So if you cross check this, never mind, I explain. So this is a communication diagram based on the prototype just now. If you scroll your note, you can see that is this is the sequence for the prototype just now. So first we get client. So actor get the client, and then the client or they will list the campaign. One, two. No, they will list the campaign, and then the client will process to this is the interaction between client and campaign where they will request to get the campaign details, and then from the campaign it will go to this one. But meanwhile, campaign manager also list advert can list the advert, and then 3.1 get advert details from this one to this one, and then 3.1 you get the add new advert, and then advert will after the campaign manager already add new advert from campaign, it will create a new advert here. So this is the communication diagram based on the prototype here. Add new advert into a campaign prototype. So this one too, this one is the message send, and this one is the process or the interaction in flow, or between the object. Okay, so this one I don't think I want to I don't think I want to expand. It's not that I don't think I want to expand, but this one is more or less like the sequence. So you just read the sequence. I think this one too is quite straightforward because you know they have this number here and then they have the message that state here between the object or what the process requests or what's the process sent to an object. So I won't go to one to I won't go to one by one on this one because I think you can read this one. So you can read, you can understand. So this is the collaboration for the use case add a new advert to campaign. Like I said, collaboration message is used to send a request between collaboration message just now is to send a request between an object to an object to send or to request for collaboration. That means they need one another. It's like a plug. No, it's not like in. Forget it. It's like they need to send a request to send for collaboration. That means they need that other object to work with them to perform a specific function. Okay, so that is collaboration. That is collaboration. Collaboration diagram. Guys, can we have break 3 minutes before we will continue at 11:30 before I proceed with this boundary and control line? Okay, thank you. So, hi guys. So, let's continue back. We need to finish this. Okay. So, just now is from the calibration diagram. We stop at calibration diagram. Mm, mm, and you mean for your assignment? If I'm not mistaken, your assignment is your function for your assignment, your module for your assignment is to add a new admin, right? So I don't think that will be complicated if you want to add a new admin. So you just draw your diagram one by one so it won't get complex, but you have time for that. So now we move to this one. Here they highlight the boundary lifeline and control lifeline. So what is boundary? This one I think also in this chapter, early in our chapter. So what is boundary lifeline and what's the difference between boundary and control lifeline? So boundary lifeline is actually the system boundary. For example, the system boundary with the actor, which is a human, is the user UI here, is user interface. So here is the boundary lifeline. That's mean the yeah, boundary lifeline. That's mean the boundary between the system and the user. So it is a UI. How the actor, the human get access is by using, it's not get access, or it's actually like how the human can view this process is by the UI, user interface. And then next we have what we call as control lifelines. Control lifeline. So control lifeline is to represent the participant, the mm, individual participant. So that's the difference between boundary lifeline and control lifeline. So let me repeat, boundary lifeline is the line, like the user interface, that how the user or how the actor can get access to this one is by using the UI. Control lifeline is the participant, the individual participant here, as you can see. Okay, that one is boundary and the control control lifeline. And then next we have a collaboration diagram. This one is again the collaboration diagram. So collaboration diagram, like I said, collaboration between two objects. So here is the alternative allocation of responsibility for use case. So add a new advert. Ah, so this is the process to get or to add a new advert. So uh, let me check first. Mm, so here is the collaboration diagram to add a new advert to a campaign. But 1 second. Oh, it's a different one. Okay, so this one is the collaboration diagram. So again, this is just a process step by step, which mean include the message between the object and what is the sequence. So that's collaboration diagram. So again, too, I don't think there's I won't say there's no need for me. I don't I mean, what I mean is, I think the process you can read because I already explained what the what is this, what is the number stand for, what is the arrow, what is the notation of this diagram. So you just link back together. So this one is the message sent from this object to this object, and then this is the notation of the message, and this is the process that requests or yeah, the collaboration that need to be done by this one. So That's pretty much what is collaboration diagram. I won't go to or it one by one for you guys. I think that's one it's quite easy for you guys to do on your own. So let's move to the next slide. So this one is the prototype. So this one is the prototype to assign staff to work on a campaign. So here we have this initialized dialog, and then the same one initialize dialog with the name or the list of client. And then again, when we click or when we select on the particular client, uh they list the campaign that are available. So here we need to assign or what is the process or what is the collaboration diagram on the assigned staff to work on a campaign. So this is the sequence from the previous slide. So client campaign, we already up to here just now. So here, as you can see, after we already select our campaign, we can add the staff because assign staff to work on our campaign prototype. So we can select the staff or we can add, as you can see, there are few function here. So they can add, and then this one is the process to assign staff to work. So this is the collaboration diagram. Mm, that I have something that I think quite important. This one. Okay. So how to come out with this okay, how to come out with this entity, or yeah, how to come out with this entity. Previously in our practical, we have like a situation in text form. Yeah, in text form we have a situation in text form. That means from the situation we highlight what is the entity, this is entity, or class, what is the entity or the class needed. But from the prototype, because now they are using prototype as a sample, so how can we get what, or how can we extract, or how can we identify what is the class here as by uh, read step by step process. For example, here in the dialog initialize, we need client and we need campaign. So do we have client? Yeah, we have a client and we have a campaign. So same goes to the next prototype. So you need to know what is the, it's like your attribute last time in our class. You need to know how to, what is the necessary attribute that you should include in your class diagram. So same with this one. You should know what is the appropriate message, or what is the collaborative message that should be sent from one object to another object. Okay, this one later maybe you will understand more if you do your tutorial. And then here is a class diagram. So like I said, yeah, so this is our class diagram. So this is our class diagram. So this is our entity or our class. So this is the relationship for the just now the science stuff collaborative diagram. So this is the relationship between the entity or between the object, and then you can find the attribute as well as the process method here down here. So that one is just a sequence from the previous collaborative diagram. That's mean from that collaborative diagram, maybe you can come out with this class diagram. So here is the communication. So here, assembling class diagram. Assembling is like uh assembling class diagram. That's mean we like, how do I say, we put together. Yeah. So here, as you can, so here as you can see, this is our participant or the class or entity that involved. So here we need to check what is the method, or what is the process done by our class. How to check? Again, we just check on the method for each of the class. So here they just explain A is campaign class that is made the next advert to a campaign. That means this campaign class have this function that perform. And then this B entity or object B here is campaign class that meets the needs of assigned staff to work on a campaign. That means like they are checking back on what they perform, what they should perform. C, this is this class name. No explanation on this. This is the syntax of class name. So that one on that one, or more fully developed campaign class meets the requirement of this several other use case. So this one is more detailed one. So that's what is the assembling class diagram. That means we check back from our class diagram with our collaborative diagram. Not only for collaborative diagram, this one I think I mentioned too in this lecture just now. I'm not sure which part. You can like cross check with your class diagram for your object on what process they should have. So now we move to interaction. When to use interaction diagram, or how, when should we use? So when interaction diagram, so when catching user requirement, describe the behavior of several objects within a single use case, show collaboration among objects. So when catching user requirement, not when we meeting with the client, I mean the user. During the meeting, the requirement gathering, we don't do this interaction diagram. This is the internal. Client do not want to see this. They do not understand. This one is for internal, what do you call it? Internal process between, usually between the developer and BA or data analyst or whoever involved. But this one is for internal. After we get the user requirement, and then after having described the object behavior completely with state and activity diagram. That means after you already know what is your process, activity diagram. So after you know what is your process, and then you already describe the object behavior, your attribute. So we can come out with this interaction diagram. And then we shouldn't use interaction diagram for precise definition of a single class behavior. Why? Because interaction diagrams, like you already see just now, is only show the sequence of the interaction, not the detail behavior. So we need you to use stat diagram. So if you want to describe the behavior across many use cases or many threads, consider an activity diagram. Like you already see, there's no behavior, there's no attribute in interaction diagram. It's only show what is the interaction between the object, class, or the entity. So here we have an exercise. This one exercise is for you guys to do. Construct a design collaboration diagram, mail online through a website. Your diagram should include relevant object creation, entity, UI, boundary control, and entity object creation, or entity object involved member, mail, and order. So they already give you hint here. So you need to do this exercise. Okay, we'll check next week. So here is a timing diagram. So what is a timing diagram? So timing diagram is actually uh, 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 timing diagram is, I think just now, timing diagram to represent the timing data. It's only for timing data for individual interaction of classifiers. So here, variance of activity diagram, you need to check back on your previous chapter, and then focus on the flow of of control in and interaction. Of course, it will concern on the flow because it is a timing diagram. So notes in the diagram may be interaction or interaction occurrence. Interaction needs to be broken down into its key element. An alternative version of the sequence diagram, add a new advert to a campaign if within budget, is shown on the next slide, and use develop interaction overview diagram. So we will see this one. Okay, by the way, interaction diagram is to show, like, to represent the timing data, because in sequence diagram, like I said, we have it's a sequence of a process in time. So this is timing wait timing diagram. An alternative, add a new advert to a campaign within a budget. Add a is shown on the next set. Interaction overview diagram. Get campaign budget is here. Get campaign budget. Okay, so this is original sequence diagram, and then from this one we get to this one. Get campaign budget. Get campaign budget here. Reference. So from this reference, so as you can see, add a new advert, we have reference to get campaign budget. So from this reference, we come out with a new sequence diagram. So this is the interaction in a sequence, but in a sequence, yeah. This one, mana tadi? This one. That's mean this one reference get timing budget. We extract. Hmm? Get campaign budget. Get campaign budget. We go to this one. So as you can see here, they have more detailed function within this reference here. So they have a loop. That's mean they're processing this one between for all campaign advert. That's mean this is just a normal process. What I want to highlight here is actually on this one. So we go to one by one first. So this one is just a campaign budget from this one, but it's more detailed on the process. Same goes to this one, create advert. Create advert is this one, alternate. Under the after the reference, we have this alternate the this function. Within this one, we have a nested reference within an alternate. So you can see create advert or to cancel. So this one from the reference just now, actually this one. But so here we already create request. Create advert or create is what request. This one is like breakdown into sequence diagram. So here we are actually. So here, as you can see, this is a sequence diagram to add a new advert to a campaign within a budget. So why like I explained quite fast just now is because, okay, here list campaign for client. So list campaign for client, as you can see, this is SD sequence diagram within this sequence diagram. So how to explain? So this is a sequence diagram within a sequence diagram, and then within this sequence diagram, this one is a get campaign budget. The one that is actually, this one is broken into this separated sequence diagram is not broken. What did you know? Separated. I mean that one. This one is the sequence diagram from the single sequence diagram just now. So here, as you can see here, we have this sequence diagram, and then we move to the next. After this sequence diagram, we have this reference. Reference is the one just now, the get campaign. After the get campaign, we we have this alternate. Alternate is create request. Alternate is this one. So under this alternate, this one is the last one before this slide. This one, create request. So create advert and create request. So create advert and create request. So like I said, the previous sequence diagram is separate. There's one term I forgot already. It's not separate, like the I don't remember. But this is the combined sequence diagram to show all the activity. So here, as you can see, this is the initial mode and interaction occurrence. That means they have the process or they have an interaction within this object. And then this is in time sequence diagram. So here, this is the decision. This one, I think you guys notice the decision, which is the alternate function. And then this is the final code. So this is what how to see the separate yeah, separate sequence diagram in a flow. It's not flow, it's like, yeah, in flow. What's the process? So this is timing diagram. So a new feature in UML 2.0 show how time constraint affect interaction between lifeline. Like I explained, lifeline is an object. So different lifeline or different object have different time to process. That's why we have slope or gradient. So the sequence diagram car enter park, or this is a situation for us. The next page. So show how time constraint affect interaction between lifeline. So this is why we have gradient or time different for processing. So this is a car enter car park. So this is a timing diagram for a car enter a car park. So I already searched what is wet sensor, but I think wet sensor in a car park is, I'm not sure what is wet sensor because I couldn't find. But I think this is something related in the car park that, for example, if the parking is empty, it's green. So if the parking is occupied or full, it's red. I think that is wet sensor. I'm not sure with this thing. So this is the process actually for a car enter a car park. So here, I won't explain this, and this, but I will explain this notation. So this notation, this is actually a situation when a car enter the parking lot. So here we have this object, and then we have this message, and we have this active, block, inactive, lowered, raised, and lowered. So what is this notation mean? So this notation mean this is a gut. So they have like certain condition they need to check. They need to check for, it's like, yeah, they have a condition that they need to meet. They need to check. So this is a condition, a gut. So I think this one new. I'm not sure if we have if I explained this notation previously, but the other notation you should know. So this is a gut. So time slope. Okay. So in the timing diagram. So in a timing diagram, so here we have a barrier and ticket machine. So they have what this situation is for the card and the car park lifeline barrier. So this one is in ticket machine. So this diagram has two uh two entity, two each, or two lifeline, two entity to object. So this is the message that sent. This is actually, don't get confused. This diagram is not actually connected, but this is only to show the message that sent from this entity to this entity. They are not connected, but they are related. related or they are associated with each other by this message. So this is a message sent by this object to this message, and then this is a time process that um, this is a time taken to process the message, and then this is the barrier lowered. So this means this is the represent the duration of state change. That means this is like the result. Yeah, the result to finish something. Slope line, this means it's a result to finish. No, slope line is not the result to finish something, but this one here is the step where it already finished the process. And then this is the message sent back to this entity, which is barrier lowered. Okay, don't see this entity as connected. They are not connected, but they are related by message or by this message sending process here. They're not connected, but they are related. Okay, so next is model consistency. So timing diagram must be consistent. Timing diagram must be consistent with the relevant sequence diagram and state machine. So summary. So in this lecture, we already cover how to develop object interaction from use case, how to model object interaction, how to cross-check between object interaction diagram and class diagram, and how to model object interaction using an interaction communication communication diagram, and how to model interaction using interaction overview diagram, and how to use timing diagram. So this one is all covered within this 90 pages slide of lecture. Okay, I know this is a lot. To me too, this is a lot. I even go to search something for this lecture too, but I think you will get familiar once you do it one by one. Okay, so I think any question? I think we can end now. I think we can dismiss now. Or any question you want to ask before we dismiss? Uh, should I do this? Not only you, me too. You need to do, because I noticed not only you, because I checked the lecture note, the CC, the lecturer that provide this lecture note, they also tag with the sources of the lecture note is from the website. So maybe if you want to understand more, you can check on the internet, do internet surfing. So I think since no question, we can dismiss now. Okay, so see you guys on Tuesday. Okay guys, bye, thank you.